Now, here's another method how to solve quadratics. It's called completing the square. And for those of you who've looked at this already and saw I need two numbers to times together 48 and add together 14, you know that the answer is 6 and 8. So ultimately your answer should be -6 and -8. But let's go through the process. So if I'm going to complete the square, I need to be thinking of those perfect square expansions that I talked about earlier. So I need to look here, and I want this x squared plus 4x to be part of a perfect square. So over here, this is my thinking. So I want something, x plus something all squared, that's going to have x squared plus 14x plus something else in there. Now we learned from expanding the perfect squares before, that when you expand a perfect square, you get the first thing squared plus 2 times the first term and the second term. So that gives me the 14x. So to go backwards, I want half the 14x. So half the 14 really is what I want, it's the 7. So if I expand this out, x plus 7 all squared, I get x squared plus 2 times x times 7, which is 14x, plus the 49. So I'm going to use that to turn this into a perfect square. So over here, I'm going to embed x squared plus 14x plus 49 into here. I'm just going to write that there now. X squared plus 14x plus 49, I'm going to put in that place. Now I want this to remain equivalent with this. So at the moment, there's a 48 there and there's a 49 here. They're not the same thing, everything else is the same. So to keep it equivalent systematically, I'm going to just put that number, my 48 there. Okay, whatever that one is, I'm just going to write it there. And because this is the extra bit I've added, I'm just going to minus it. So the 49, take the 49, it's like it was never there, and I'm left with the x squared plus 14x plus 48, which is the original question. Now, the reason we do this, though, is because what I've written here, hopefully you'll notice, it is x plus 7 all squared. So instead of writing that now, I can write x plus 7 all squared. That just replaces that. And I can fix this up and just add it up and work it out, simplify it. So 48 minus 49 is minus 1. Okay, now I've got something to solve just like we were doing a minute ago. So I want to get the x by itself. I need to just get that 1 onto the other side of the equation. X plus 7 all squared is equal to 1. So square it both sides. I get x plus 7 is equal to the plus or minus 1 in both cases. So therefore, x is equal to, what am I doing? 1 minus 7, which is minus 6, or x is equal to 1 minus 1 minus 7, which gives me the minus 8. And I believe that's what we predicted we'd end up with in the first place. Okay, let's do another example. So I'll clear that. You can follow again. Okay, make this example B. Okay, so let's do x squared minus 4x minus 12 equals 0. Okay, so first thing to do is think about perfect squares. Over here on the side, have a bit of a think. I want x plus something all squared, and it's going to be x squared minus 4x and some other number. Now remember, we need this number here needs to be half this number, the coefficient of the x there. So it's not just 4, it's minus 4. We actually need minus 2 in there. So that means if we expand x minus 2 all squared, we'd get x squared minus x times minus 2 times 2, which will give us the minus 4, and then have to do the minus 2 times minus 2, which gives us the plus 4. Watch your signs. Okay, so I want to embed that x squared minus 4x minus plus 4 in the actual equation. So over here, I'm now going to put x squared minus 4x plus 4, just leave it there. And now I need to fix up what I've added and subtracted and things to make things in balance. So I've used that, but I haven't used my minus 12, I need to put that in there. And my plus 4 was extra, I added that in there, so I want to take it away to keep it all in balance. Okay, I've got this statement here. The whole reason I put it in there is because I know it's x minus 2 all squared. X minus 2 all squared. And now I just fix that up. Minus 12 minus 4 more is minus 16 is equal to 0. Now I want to solve this. Put the 16 on the other side. So I've got x minus 2 all squared is equal to 16. Square root both sides. X minus 2 is equal to plus or minus 4. Always remembering there are two answers when you square root something. So therefore, x is equal to 4 plus 2, which is 6, or x is equal to minus 4 plus 2, which is minus 2. And there are two answers. Okay, I'm going to do one more. One more. Sample C. Okay, let's do x squared plus 3x minus 4. Okay, we're going to do it by completing the square, which means we need to go over here to the side and think about, I want x something all squared, it's going to give me x squared plus 3x something else. Now plus 3x. The last two I did, I had even numbers, so when I divided by 2, they were nice whole numbers. Doesn't matter, you can still divide 3 by 2, it'll give us 1.5. It always looks a bit strange to not have whole numbers, but they function the same as any other number. So, I would square the first term, x squared. 2 times x times 1.5 gives me my 3x, plus 1.5 squared. So you might need your calculator out. What's 1.5 squared? It is 2.25. Okay, again, I'm now going to embed that over here. So I'm going to write x squared plus 3x plus 2.25. Okay, and I haven't put in this minus 4 yet, and I need to counteract that 2.25 by taking it away. So that now I have equivalent statements there. So, just like we did the last 2 times, this is already, we know, it is x plus 1.5 all squared. And we just need to simplify minus 4 minus another 2 1/4, so that's minus 6.25. Get that on the other side, x plus 1.5 squared equals 6.25. I need to square it both sides. And so I get x plus 1.5 is equal to the square root of 6.25 is plus or minus, 2 possibilities, 2.5. So therefore, x is equal to 2.5 minus 1.5, which is 1, or x is equal to, we've got the minus 2.5, take away the 1.5, and I believe that might be minus 4.